Bismillahirrahmanirrahim. Welcome to the first part of the seventh lecture of Statistics and Probability Theory. In previous lecture, we have discussed reliability analysis. In reliability analysis, we have discussed two types of systems in series and parallel. We have discussed that how we can find out the reliability of any of the system by applying the previous laws we have studied, like addition law of probability, multiplicative law for independent events. We have discussed some examples in previous lectures. Today's topic is random variable. Random variable, let us define first what is the random variable is. A real valued function defined on a sample space of a random experiment is known as random variable. What is the random variable? We already know that whenever we perform an experiment under uniform conditions and we have more than one outcome of the random experiment and the outcome is unpredictable, so the experiment is known as random experiment. A list of all possible outcomes of random experiment is called sample space. Now, a real valued function, if we defined a real valued function on that particular sample space, it is known as the random variable. Let us consider the simple example. If we toss a coin, this is a random experiment. That is, the experiment is performed any number of times under uniform conditions and we have more than possible outcome like head and tail, and outcome is unpredictable, like when we toss a coin, we don't know either the head will occur or the tail will occur. So the sample space would be head and tail. Random variable, let us denote the random variable with x. You can find in some books it could be x, it could be y, it could be z. Usually the capital letters of the alphabet and mostly they are the last capitals of the alphabet x, y, z, etc. Now, what we are going to do, we simply associate a number with the possible outcome. Like we are saying, it is a real valued function defined on a sample space. So, if the head occurs, we will represent it 1. If the tail occurs, we will represent it with 0. So, if we perform a random experiment and the outcomes are represented by x and this is a random variable, you know what is the random variable? Something which is not fixed. So, whenever we mention x is equal to 0, it means we are talking about or we are referring to tail. Or whenever we write x is equal to 1, it means we are referring towards head. Usually you can find in the books that x represents x1, x2, x3. This is small x. This capital X have values x1, small x2, small x3, up to so on. How many values a random variable can possess? It could be till x n. So here we have two values of a random variable. So small x1 is equal to 0 and small x2 is equal to 1. So this is the random variable x possessing two values 0 and 1. What we have done, we simply associate the real valued function x with the sample space of a random variable of a random experiment. Now, let's suppose three coins are tossed together. The sample space will be head, 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 tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, tail, tail, and tail. There should be 8 possible outcomes. As we know, if we toss a single coin, there would be 2 possible outcomes. If we toss 2 coins, there would be 2 cross 2 is equal to 4 outcomes. If we toss 3 coins together or we toss a single coin 3 times, there would be 2 cross 2 cross 2. It means there would be 8 possible outcomes. So if we toss a coin 1 time, the possible outcomes in our sample space would be 2 raised to power 1. If we toss 2 coins together, the possible outcome would be 2 raised to power 2. If we toss 3 coins, the possible outcomes would be 2 raised to power 3. Similarly, if we toss 4 coins together, possible outcomes would be 2 raised to power 4. Now, let's suppose we are interested in number of heads. We are performing a random experiment and we are interested in the number of heads, that how many heads are occurring. So, let us associate a random variable with the number of heads, that is x is equal to number of heads. So, what's happening here? How many values x could possess? If you concentrate on the sample space, what possible outcomes are? If we concentrate here, how many heads are there? There is no head in this possible outcome. So if there is no head, we will represent it with 0. Like if we say x is equal to 0, it means there is no head in the possible outcome and there is only one possible outcome in which there is no head. Now, if you concentrate on this outcome, and this outcome, there is only one head. So, x is equal to 1 means the outcome which possess one head. If you concentrate on this outcome, and this outcome, it means all of these outcomes have 2 heads. And if you concentrate on this outcome, it possesses 3 heads. So these are the all possible values the random variable x could possess. X is equal to number of heads. So if x is equal to 0, it means there is no head in the possible outcome. If x is equal to 1, it means there is only one head in the outcome of the tossing of a coin. If x is equal to 2, it means there are 2 heads in the possible outcome. And if x is equal to 3, it means that there are 3 heads in the possible outcome. Now, what we can see from here, these are the outcomes. These are the outcomes when 3 coins tossed together. These are 8 possible outcomes, right? Now, number of heads. X is equal to 3. There are 3 heads. X is equal to 2. 2 heads, as we have explained in previous slide. X is equal to 2. X is equal to 2. X is equal to 1. It means there is only one head. X is equal to 1. It means only one head. X is equal to 1. It means only one head. X is equal to 0. It means there are 3 heads. If we find out the probability of the possible outcome, it would be 1 by 8. Number of favorable outcomes divided by total number of outcomes. This is the probability that the outcome triple H will come. How many times in a sample space H occur? It is only one time. The favorable outcome is 1 and total number of outcomes is 8. So, what we can see here, X is a random variable. You can name it Y, 2, Z, X, Y, Z, anything. Here we have mentioned X. So, we are interested in the number of heads. So, we have mentioned X is equal to number of heads and X is equal to 0 represents the outcome which possess no heads. Similarly, 1, 2 and 3. Let's suppose I am interested the number of tails. Let me denote Y is equal to number of tails So what we can have, Y is equal to 0. What does it represent? It represents the outcome which have no tails. This one is the outcome which have no tails. Y is equal to 1 means the outcome which has one tail. This one is the outcome which have one tail. This one is the outcome which have one tail. And this one is the outcome which have one tail. Y is equal to 2 represents the outcome which have two tails, and Y is equal to 3 means the outcomes which have 3 tails like this one. Similarly, you can associate a random variable with the number of tails. So random variable is a real valued function which we associate with the sample space of a random experiment.